Today I'm going to show you how to do a pre-installation verification, also known as a PIV. The purpose of this is to verify that the installer, the tool, and the installation method work together effectively to achieve at least 105% of minimum bolt tension. I would like to point out 4 of the 6 important requirements when doing the pre-installation verification. Number 1 is it has to be done on site. Number 2 is that prior to any placement of bolt assemblies in any of the work, this has to be done. And then you need to test at least 3 of the complete bolting assemblies of each diameter, each length of every lot and grade. And then the other one is that it has to be in coordinates with the test procedures that you'll see in section 7.2 of the RCSC book. There is a complete list of these requirements in section 7 in the book that you can refer back to as needed. There are 5 methods of installation that you will need to do a pre-installation verification for. There is the turn nut method, which I'm going to show you today. There is the calibrated wrench method. There is the shear wrench method, the DTI method, and the combined method. Like I said, today I'm going to show you how to do the turn nut method using a TN33 Skidmore that you see here, and then a Milwaukee impact wrench. So first what you got to do is install your bolting assembly into your bolt tension calibration unit. And in this case what I need, because the bolt is a little bit too long, I'm going to be using a spacer kit, or a piece of a spacer kit. So you want to put that in after you put the bolt on. Then you got to put your washer, and then you've got to put your turning element, being the nut, and make sure that you are just about flush with the tip of the bolt. And now you need to snug. Now remember, you need to use the same equipment that you're using in the actual work as you're doing with the pre-installation verification. So now we'll snug it. And we'll match mark. And you're going to pick a point on the nut, and you're going to mark halfway across the end of the bolt on that point of the nut, and then on the plate. And in this case, because of the diameter and the length of this particular bolt, it's a 1-inch diameter bolt. We're going to go 120 degrees, which each point on this nut is 60 degrees. So we're going to go to the second point up this way, and we should land with this mark right about there. And here's the TN33 that is actually set to 120 degrees on these 3 dials right here. Now in this particular tool, when you pull the trigger, you want to hold that trigger until the tool stops on its own. If you start feathering this, it's going to restart its counting every time you pull that trigger. So just hold it until it stops on its own. So as you can see, the 2 marks match up, and we are above minimum tension. In this case, with the 1-inch diameter bolt, we should have been at or above 54 kips, and we are definitely over 54 kips, and everything matches up, so call that good. So on occasion you might get the tool stuck, and in this case there are multiple reasons why, but in this case there are 2 ways to get the tool off of the bolt that it's stuck on. You can do it manually, just in case you don't have reverse, and that means basically turning this thing counterclockwise until it starts to loosen up. It takes about a few times, and see, now it's loose. The other way is if you have reverse installed on the tool, you've got a little switch on the bottom. You just click that into reverse, tap the trigger, and you can get the tool off.